Well, hello. Here's your nudge video, if you need it, for MOP WM5 in the waves unit. MOP 5 is all about what happens to a wave pulse when it's going through one medium and hits a boundary with another medium. So we usually describe the medium as either being dense or not as dense. So we use the words like more dense and less dense. Sometimes we'll use the terms rigid and loose, or rigid and not as rigid. So in the lab, we tend to use things like slinkies, which are very loose, and then snakies, which are very tight and rigid. So here we have a blue medium, which is very dense, and they even draw it this way. So this is a dense medium in blue, and then the less dense medium is shown in red. And what's going to happen here is that eventually this wave pulse traveling rightward is going to get to the boundary that I just marked there in green, and then it's going to split into two separate wave pulses. We have a little bit of the wave energy that comes back through the blue medium, that's called the reflected wave pulse, and we have part of it that goes forward and is transmitted into the new medium, the red one in this case, and we call that the transmission or the transmitted wave pulse. So you have to know important characteristics of a more dense medium compared to a less. And this is something that's easy to see when you use a slinky and a snaky. The loose or less dense medium has a much easier time moving around, and therefore the waves travel faster through them. And so when you look at what's happened, for example, in A here, look at how far the reflected wave has gone from that boundary compared to the much greater distance that the transmitted pulse has gone. So that's clearly showing that the wave pulse is traveling faster in the red medium. So you have to know, is that an appropriate distance to travel in a less dense medium? The other thing to look at is whether the waves are inverted or not when they reflect or transmit. So in figure A, notice both wave pulses are crests, just like the original wave pulse went in. But in figure B, which I'll circle here in gold, you see how it's been inverted. So here's another important characteristics to look at. Should a wave pulse be inverted when it's hitting a less dense medium? That's something that's clearly described in the tutorial, and you can see figures like that. So look for things like inversion of the reflected pulse, or, as you see here in C, inversion of the transmitted pulse. Is that appropriate going into a less dense medium? So those two combinations of how fast the wave pulse must be traveling in each medium and whether it's inverted or not is how you're going to choose from among the 5 choices that you have. So hopefully that's enough to get you started. Ask questions by seeing me in the classroom.